Hello class, this tutorial is going to be about confidence intervals. It's going to be a review of confidence intervals for around an average, okay? And if you recall from class, we rarely know the true population average, proportion, or standard deviation, right? So when we sample, we want to create an envelope around which we can say with some confidence, some authority, what the true average, where the true average may reside, okay? And that's what the confidence interval does. And confidence intervals are done for average, proportion, standard deviations, etc. For an average, the confidence interval is calculated by taking the average and adding and subtracting the product of the t-value based upon the sample size and the standard error of the mean. We've talked about how to what the t-value is and the t-distribution and the standard error of the mean, so we're not going to go into depth on that in this tutorial. Okay, so a common confidence interval to apply around an average is actually the 95%, okay? So we're going to create a 95% confidence interval in 6 steps, okay? So we're going to find the average, find the standard deviation of the sample, then we're going to calculate the standard error of the mean, right there, determine the value of t from the table, right there, and then determine the margin right here, the envelope, and then adding, subtracting to complete that envelope. And that envelope is our confidence interval, and will be at 95%. Okay, so in this case, in this example, 10 drills were tested under load to determine their time to failure. These are in hours. Okay, so here are the individual data points. There are 10 of them. N is 10. Okay, so our average is 2.7. One thing to remind yourself here, every time we would take if we're going to sample this, the population of drills for this given product, we're going to get a slightly different average, okay? And that's why we need to calculate this standard error of the mean, because it's a probability distribution for your averages, okay? Not for your individual samples, but for your averages, okay? So for our step 2, we need to calculate our sample standard deviation, okay? So we have our average, which is 2.7, right there. And although we're not going to go into detail here, our sample standard deviation is 1.337, okay? So far, we've calculated, we have our average 2.7 plus or minus TS of x bar. So we haven't calculated that yet. So we're going to calculate now the standard error of the mean, all right? And now that we have our S, and we know what our sample size is, N, right here, we can calculate standard error of the mean, all right? And that comes out to 4.23. Okay, so a little note on the standard error of the mean, all right? If we wanted to increase or decrease standard error of the mean, how would you do that? Well, if you want to decrease this value and therefore decrease your confidence interval range, basically you're trying to become more precise in that and more accurate, you would have to increase your sample size, given that you haven't changed what your standard deviation is, okay? But you can also, for whatever process that you are measuring or the process that's producing them, if you have a wide standard deviation, there may be some process steps that you can do to decrease it there as well. Okay, so now if we have it 2.7 plus minus t times the standard error of the mean, which is 4.23. Okay, so now we have to look up t. All right. This is the data that we have already calculated. So in the back of the book, if you remember, in the t table, we need to determine our degrees of freedom, and that's what this is written as right here. N minus 1 is degrees of freedom. That's 9. And then the reason why it's written here as alpha divided by 2, n minus 1, is that it's a two-tailed test. Two-tailed interval right here, so plus or minus. Alright? So it's alpha divided by 2, which is 0.025. So we need this and this to go back into the book, and we come with a value of 2.262 for t value, which is plugged in right there. So I already talked about this, so when looking at a table, make sure to see if the table itself is set up two-sided or one-sided. Okay? And we talked about how to determine t for two-sided or tailed 95% confidence interval. Okay? And that's the information for that. So for our confidence interval right here, so we know we have all the factors right here. 2.7 plus or minus t times standard error of the mean. All right? And that comes out to right here, so we have 2.7, and our envelope right here is 0.957. Okay. So we can say that we are 95% confident that our average time to failure for drills will be between 1.74 and 3.66 hours. Okay? That's where the true population average will reside. Okay? And if you recall, for t, if we had a higher sample, that t value is going to decrease a little bit. So basically, these values here, the smaller your sample size is, we're not as confident. All right, there's more slop in that, if you will. Okay, so that's what's going to happen. Is this is going to be larger. Also, if we want to be more confident in our envelope, we can do that too, and it's going to increase. All right. So if we move from say 95% to 99%, what happens is that t-value is going to increase. All right? So we know our alpha value is 0.01 right here. You have to divide that by 2 because it's a two-tailed test, and it's 3.250. Okay? That's larger than for 95% confidence. Okay? And our range then increases. So if we want to say we are 99% confident, our we are 99% confident that our average resides, our true population average resides between 1.37 and 4.07. Okay? So that is the end of the tutorial for confidence intervals for averages. Thanks.